This is lesson 6.8, and we're going to be talking about graphing radical functions. Now, the most basic radical function is y equals the square root of x. And so to do that, let's make an xy chart. And when we take the square root, we want to have real numbers. And so we're going to have to start with a 0. We can't put any negative values in because we can't take the square root of a negative. And if we do, it turns into imaginary. So if we plug in 0, we get square root of 0 is 0. And then you could put any positive number in, but let's pick a nice perfect square. So the next biggest one would be 1. Square root of 1 is 1. Square root of 4 is 2. 9 is the next perfect square. Square root of 9 is 3. And so when we graph that, let me pick a different color here. We have 0, 0, 1, 1, 4, 2, 5, 6, 7, 8, 9, 3. So this is how your square root of x graph looks. Now, as far as the domain and the range of that, the domain is talking about the x values. So if you look across the x-axis, there are no values, no negative inputs that we could put in. And so the smallest it could be would be 0. And from there on, it's the positive values, all the numbers greater than 0. So like here, if you put in 4, the output's 2. If we put in 5, the output would be a little more than 2. If we put 6, it'd be a little more than that. So we would say the domain is all the values of x greater than or equal to 0. Your range, that's talking about the y values. So if you look at the y-axis, there are no y values until 0. And again, because 0 is the smallest we put in, the smallest that could come out would be 0. So all of your y values, your outputs are above 0. So y is greater than or equal to 0. The next radical function we're going to graph is a cubed root of x. So again, we'll make an xy chart. Now, we want to write down the perfect cubes. That will be easiest. Let's start with 0. Cube root of 0 is 0. The next perfect cube is 1. The cube root of that is 1. The next biggest perfect cube is 8. The cube root of 8 is 2. Now, we can take the cube roots of negatives. Like if we plugged in a negative 1, the cube root of negative 1 is negative 1. If we plugged in a negative 8, the cube root of negative 8 is negative 2. So let's go ahead and graph those points, 0, 0, 1, 1, 8, 2. All right, negative 1, and negative 8, negative 2. Right here. So this is the shape that we get with a cubed root graph, kind of a flat S shape. Now, as far as your domain and your range, for the inputs for your x's, we can put in positive numbers, we can put in negative numbers, and we can plug in 0. And so for the domain, we say it's all real numbers. And your range, because you're plugging in all real numbers, the output could be all real numbers. And so it's all reals. All right, let's look at some of the shifts here. It's a little bit hard to see here. The red graph is the square root of x is hiding behind there. And you can see we have 0, 0, 4, 2, 1, 1. Where's 1, 1? Probably 1, 1 right here. All right, that is your parent function. And now if the blue graph is the square root of x plus 2. Let's look at what that did. What that did is it shifted it 2 to the left. So you'll notice when this was a plus 2, all of the points went 2 to the left. When we had x minus 3, so that negative is inside the parentheses, the green graph shows that it went over to 3. It shifted to the right. So when this was a minus 3, it shifted right 3. When it was a plus 2, it shifted to the left 2. Now here, again, we have the square root of x, is this right here. The next one, when I added 2, look what that did. It shifted it up 2. So this went up 2. When I subtracted 3, let me move this down, it went from 0, 0 down to 3. It went down 3. Here we have cube roots. The top one again is hidden. That's the blue one. This is your cubed root graph. And you'll notice when we put in the cube root of x plus 2, that's the black one, it went to the left 2. So when it was a plus 2, it went left 2. And then the cube root of x minus 3, that's the red one, that went to the right 3. And then in the next set, cube root of x, that's the blue graph. Cube root of x plus 2, the black graph, it shifted up 2. And then the red graph shifted down 3. So this is up 2, this is down 3. So that brings us to the basic way that our root graphs are going to be, or our radical graphs. The h inside the root is the right-left shift. If this is a negative, it's going to shift to the right, and when it's positive, it shifts to the left. The k, the number at the end, is your up-down shift. So if it's positive, it shifts up. If it's negative, it shifts down. And it works, that pattern works with all radical functions. And the a value, that is your shrinking or your, it's going to either flatten it or it's going to go up higher and faster. All right, so how do we graph when we have a lot of stuff going on here? Now you could make an XY chart, but that would be a little bit challenging. So my handy tip here is to put a box around this all the way up to where the X is. And make an XY chart for that, because that won't be too difficult. And when we're doing a square root, list the perfect squares, 0, 1, 4, and 9. So we're going to substitute that in for just this part right here, from here and over. So the square root of 0 is 0, times a half is 0. The square root of 1 is 1, times negative 1/2 is negative 1/2. The square root of 4 is 2, times a half is negative 1. The square root of 9 is 3, times a negative 1/2 is negative 3/2, which is equal to negative 1.5. So let's graph that. We're just going to graph those points because we're not done yet. So if we go over 1, we're down 1/2. Over 4, we're down 1. Over 9, we're down 1.5. So that's the general shape of this. But now we have an h and a k value. And now remember, if this is showing a negative 3, it's actually going to go 3 to the right. And when this is a plus 1, it's going to go 1 up. So now we're going to take every point, and let's use another color. We're going to go 3 to the right and up 1. 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 Now this is the final graph. Okay? Now as far as your domain and your range, the domain is the x value. So if you look across here at the x-axis, the x values don't start until this point right here when x is 3. And so the first point would be x is equal to 3, so it's going to be x is greater than or equal to 3. Notice that's this number right here. The range, those are your outputs. So if we're looking at the y-axis, there are no values up here. Okay, this is the highest any of your values go right here, and that is when y is 1. And all of these values are below that point. So y would be less than or equal to 1. And notice that is this number right here. All right, let's go to this next one. This is a cube root, and there's a lot going on here. So again, we're going to put a box around the first part and make an XY chart for that. And we will list the perfect cubes, and we will do some positives and some negatives. So cube root of 0 is 0 times 2 is 0. Cube root of 1 is 1 times 2 is 2. Cube root of 8 is 2 times 2 is 4. Cube root of negative 1 is a negative 1 times 2 is a negative 2. Cube root of negative 8 is a negative 2 times 2 is negative 4. So we have 0, 0, 1, 2, 8, 4, negative 1, negative 2. All right, so those are the initial points. But now we have to do the shift. So when it's a plus 1, we're going to go to the left 1. And when it's a minus 4, we're going to go down 4. So let's move this up a little bit here. So take every point. To the left 1, down 1, 2, 3, 4. To the left 1, down 1, 2, 3, 4. Left 1, down 4. Left 1, down 4. Left 1, down 4. This is where our final graph is. All right, so as far as your domain and your range, we could put positives in, negatives in, 0 in, so it would be all reals. And for the range, your outputs would be all reals as well. So again, when you're doing your cube root functions, your domain and range will always be all real numbers. And that's it for this lesson. So go ahead and let me know if you have any questions. Thanks for watching.